Now, Peltiers are really great for solar power applications because they take pure DC. Here's some examples of what Peltier elements typically look like. They're just small sandwiches of ceramic. There's ceramic on either side, and they're sealed off around the corners with a sealant compound. Depending on where they come from, they might use slightly different materials, but pretty much they're the same thing. They're pretty fragile. They're made out of almost like a ceramic or porcelain kind of material. So this Peltier expects basically 12 volts DC. In reality, though, with a current limited source, you won't necessarily get 12 volts across the junctions. You'll get maybe 3 volts, you might get 5 volts. It depends on a lot of different factors. In other words, if you hook a solar panel up to one of these, you might burn it out, or you might get 5 volts, or it might be just right. Sometimes it just doesn't work like you expect. In addition to that, when the temperature changes on this element, the behavior and the voltage you might see across it changes as well. It can be quite tricky trying to figure out how to drive these things. If you put too much voltage and too much current through one of these, it just doesn't work very well. It becomes very inefficient. Even though it's not the main focus of what I've been using these Peltiers for, I do want to show that they can be used to generate power. So let's hook a multimeter up to this particular element here, and let's see if we get any kind of a reading on it. Right now you can see there's 0.2 millivolts on the meter, and that's not very much. I'll just move this so you can see better. Now what I'm going to do is I'm going to lay an aluminum bar underneath. So take the aluminum bar, and you'll see almost immediately there starts to become a voltage generated across that Peltier module. It's not very much, but obviously there is a voltage being generated, and it's reducing at some point. Now what I'm going to do is put my finger on top. You can see it starts to go up. Let's take my hand and put it across the top. You can see it's going up to 30 millivolts. So the way Peltiers work is they work off the differential. If you're generating power, you have to create a cold side and a hot side. Of course, there's limits to that. And here I'm not doing any active cooling, and I'm just warming it up with my hand. And that does produce some power. You can see right there, it's producing quite a bit more. Anyway, to generate power, you need to have a differential, so you would need to really cool one side and then get some heat into the other side. So this would be the side you put the heat into, and then on the aluminum side, you'd want to pull as much heat out as you could, and it would generate power. That's the theory anyway. Now what I'm trying to do is refrigeration and air conditioning, and I've heard it said that Peltiers are 5% efficient when moving heat. That's really not true. They can be much more than that. The key here is if you're going to use a Peltier for air conditioning, refrigeration, things like that, you need to make sure you have good cooling. And Peltiers generate a lot of excess heat, just like any other heat pump. Heat pumps actually generate waste heat, so do Peltiers. There's really a direct comparison between, say, a refrigerant-based system and a Peltier unit like this. This Peltier unit produces quite a bit of waste heat, in addition to the heat that it moves out. But so does a heat pump. The compressor gets hot, and it generates quite a lot of heat because it's an appliance, and it's wasting some of the power that goes in, believe it or not. So there are problems there as well. With Peltiers, it's absolutely critical to get the heat out, because if you don't, it just doesn't work well. And the heat means the heat you're taking out of the space, or the freezer, or your room, or whatever, as well as the heat that this Peltier generates as part of its operation. Now let's assume that I have a solar panel that's putting out around 16 volts, and in the upper right-hand corner of the screen, I have a bench power supply. You can see that right there. Let's assume it's a solar panel and it can only put out a couple of amps. Let's hook that up to a Peltier and let's see what happens. I'm going to go ahead and use this one here. This is another type that I have. You can get these on online auction sites, retail sites. There's really a good supply of them. However, sometimes they don't work like they say. For example, they may say it's a 6 amp element, and it doesn't draw 6 amps. Unfortunately, I've tried the higher power ones, and most of them don't work like they're supposed to. They don't draw anything like what they are supposed to, but that's not a surprise. Okay, let's hook this up, positive and negative. And immediately this side gets hot. Okay, so what I did is I turned the current down because I don't have any heat sinks or anything on this element, and they get hot pretty quick. This is the hot side, and the underside is the cold side. So I'm going to go ahead and connect it again. And it's getting pretty hot. So Peltiers change in real time based on the temperature, and the way they perform may change depending on the conditions. And it's interesting to note how they behave. If you change the temperature like I'm doing now by putting my hand on it, it starts to change. If I take my hand off, it goes up. You see? I'll do it again. So it's very sensitive to temperature changes. Now if I put the Peltier on some kind of a heatsink, here's the heatsink, it's just a water block, and then put it on another heatsink, so both sides have a heatsink. I can go ahead and hook it up, and now it's going to be able to effectively pump that heat a lot more easily because now it has a heatsink on both sides. Peltiers need to be heat sinked on both sides. So obviously the warm side is on the bottom right now, so this side should be getting cold. So I'm going to turn the current up a little bit because I have some heat sinking. You can see as I increase the current, the voltage will rise. And I'm not going to push it too hard because I don't have any heat sinking compound on these blocks here. It's just a test. And I can tell you that this is getting really cool. And this bar is starting to get warm. I've placed some black tape on the metal there because this infrared thermometer can't handle reading shiny silver metal. We're going to go ahead and point it at the white background. It's about 74, and that's the heatsink side. So it's about 95 degrees Fahrenheit, and that's about 35 Celsius. Now if I move it over here, it's about 60 something. It's in the low 60s. That tape isn't sticking very well. About 60, yeah, if the tape sticks well, this tape is coming off. Yeah, it's getting down in the low 60s, which is 16 Celsius, 59 degrees, 58. It's getting colder. You can see how quickly that takes effect. Really, I should put a thermocouple on here, but there we go, 59 degrees. And that's 6.7 volts and 1.5 amps. But you can see that it's not running at 12 volts. That's because Peltiers change their behavior, they have different resistances, and it's actually quite tricky sometimes to get them to operate the way you want. With a solar panel, of course, it's limited on how much current it can supply. Let's assume my solar panel can put out 1.5 volts. Well, you're looking at the performance you're going to get. 1.5 amps, that's the most the solar panel can deliver. You end up with about 6 volts. And of course this is a simulated solar panel. It is powered by solar, but it's going through my battery bank. But still, a solar panel acts similarly. It's a current limited source. Therefore, if you're going to drive Peltiers directly off of solar panels, you have to be careful because the voltage can swing too high and burn them out. Ironically, this is very similar to the issue you have with a direct drive solar electric space heater. If the voltage swings too high, it can burn out the heating element. So if you're driving a solar panel into this Peltier element, it's possible that if you didn't do the math properly, what can happen is it can overheat and burn out. I can tell you right now this bar is getting pretty hot, so I'm going to disconnect it. I don't want to burn out the Peltier element. It requires heatsink compound to properly transfer the heat, and I haven't put any on there, so it's a bit risky to run it this way. Anyway, this bar here is quite hot. It's almost too hot to touch right here. Very interesting that Peltier elements with basically no moving parts can pump heat out of the cold side and onto the hot side, and they do a pretty good job. In no way, shape, or form are they 5% efficient. If you actually take one of these Peltier units and put it on the bench and test it, you will see it's quite good at doing what it advertises. It actually moves heat out of the cold side and onto the hot side. It's just that you have to get rid of the heat on the hot side, or it doesn't work properly. So it's really a game of removing heat as the Peltier unit takes it out. One last test I want to do is I want to take a multimeter and put it on here and see how much power or voltage that it's generating. And it's about 600 millivolts, so 600, of course it's falling because the differential is falling. So not even half a volt. Now of course if I were to put more heat on there and do a better job cooling it, that would be a different story. So a half a volt under very weak conditions with not much heat. It's pretty interesting that you can generate power with Peltiers. Now let's also see how much current is going to come out of there. Actually we're getting about 200 milliamps. That's very interesting. Of course it falls away quickly because there's no heat supply coming in. I'm just using the heat in that aluminum bar that's left over from the test. But still, 1 to 200 milliamps right off the bat. That's pretty good. So you can certainly generate power with Peltier elements, and I may look into that in the future. But right now my main concern is with using them for a heat pump. And a solid-state heat pump with no moving parts that can run directly off of solar panels is incredibly interesting and intriguing. So I'm doing a lot of research on this topic, and I hope to have some more videos uploaded soon showing my work. So that concludes this quick look at Peltier elements. If you have any questions, feel free to let me know. All related video and playlist links are posted in the description down below. Thanks for watching and hope to see you next time.